Now these ordered pairs certainly do seem random, and they are, but you can actually connect some of these points with each other, and they actually form patterns, perhaps actual shapes or lines. That's what we're going to be talking about next, how these patterns are formed. Now this is my attempt at drawing a function machine. The worksheets that come home in the lower grades, the lower elementary grades, sometimes will draw something that looks a little like this, where they say if you put a number into this function machine and then do something to it, that would be add, subtract, multiply, divide usually, the answer will come out of that machine. So they talk about input and then doing something to the machine, or doing something to the input, which would be the rule, and then having something come out of the machine being the answer. So input would be basically your x term on the coordinate plane, and your output would basically be your y term, or the y-axis. So if we had like a small chart here, perhaps we could say our x is here and our y is here. Remember that the two of them together are going to form the ordered pair. So if you had, perhaps this would be the worksheet, maybe you would have like maybe a 7 and 11, and maybe a 13 and a 17. We're trying to figure out what is the relationship between the first term, 7, and the last term, y. So you could imagine that you would put a 7 into this machine. How would it be possible? What could you possibly do to the 7 in order to have it come out of the machine as an 11? Well, your 7 is getting larger. So the relationship here is either one of addition or multiplication. The number that you would possibly add to this to make it 11 could possibly be a 4. That would give you 11. I can't think of anything that you could multiply 7 by in order to get an 11. Let's see if that rule follows for 13 and 17. If you put a 13 into the machine and added 4 to it, it would come out of the machine as 17. So the rule holds for this one too. So what if we did a 20? Into the machine goes 20. We're going to apply our rule, which says add 4. That's the rule. So we're going to add 4 to the 20, and our output would be 24. So coming out, a 24. The worksheet possibly would give you a 29 on this side. This time we have the output number. We don't know what went in. So we'd have 29 coming out. So our rule says add 4. That means whatever went in, x, plus 4 equals what comes out. We have 29. So this time we are actually looking for the start number on this. So from the start number we're going to add 4. And now we have an algebraic equation, because our box, or our unknown right here, can be figured out by doing the opposite of adding 4. In other words, we're going to take our 4 and subtract it from this side of our equation and subtract it from this side of the equation, just like we learned in the inverse operations. This cancels out, so we're only left with the x on this side equals 25. So our x term, even though we didn't know it, we could figure it out by doing the inverse operation. So now let's check it out. 25, if we put 25 in and added 4 to it, we would definitely get a 29. So it's true. And this is how you would figure out your input and output, or basically your x and your y. That's a function coming in as 1, doing something to it, and having the answer come out. So when we're done with this particular grid, we now have the ordered pairs. See, those are the ordered pairs. They're all set up for us. And we can plot them then on a graph. If we came to a graph, here's our x-axis and our y-axis. We could actually plot 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Our dot would go there. That would be 7, 11. If we plotted 13, we have 7, 8, 9, 10, 11, 12, 13. And then we would go, this is at 11, 12, 13, 14, 15, 16, 17. So coming over here, we would have our second dot right there as 13 and 17. And the next one would be at 20. So this is 13, 14, 15, 16, 17, 18, 19, 20. And we would go up 24. Here's we're at 17, 18, 19, 20, 21, 22, 23, 24. So coming over here, we would be approximately there for our 20, 24. And now you can see the pattern of this function is a line. I missed that dot. I'll make it bigger. That is going in this direction. So our function gives our dots an order to them that this chart didn't have. This chart had a randomly placed dots on it. But these points, if they went through a function machine, like this one, we would get an orderly pattern. And this is called a linear equation.